Today we're going to have a quick look at lambda functions. Now these are anonymous functions, functions which don't need a definition somewhere in your file to exist. We can create them as throwaway functions in the middle of another function definition. This just gives us a little bit more flexibility when we're working with higher order functions to supply anything we could want. So let's have a look at what we've got here. We've got a list of numbers 1 to 10, and then we've got the list of pairs from 1 to 10. And we've got a little description here saying that a lambda looks something like this. This slash is used because it looks somewhat like a lambda. So it's a slash, the variables, and then an arrow, and then the function definition. So slash, what you're going to supply as input, and then what you're going to do with that input. So let's have a look at how we would use this in practice. So for example, say we wanted to square all of the numbers in our list A. Well, we might want to use map for that. And map needs a function. So we need to put something in here that's going to take every number and multiply it by itself. Well, that's very easy with lambda, so what we would do is we'd say slash x, we take an x as input, whatever that x is, and we return x times x. And there we go, we get the square of the numbers 1 to 100. Now of course, we could do something more complex with this. We could say, for example, I want to say what is which of these numbers are divisible by 2. That's a little bit more of a complex definition than the previous one. And we get a list true, false, false, true, so on and so forth. So these lambda functions are often used in place of things that are quite simple, things that you wouldn't want to have to bother to define elsewhere in your file. I mean, you could equivalently use something, you could define an even function and use that instead of that lambda, but this is just a quick way to write it on the fly as you need. And we can of course take more complex input. This is just taking integers in the first instance, but of course we can take whatever we would like as input as long as we've got something that can work with it on the right hand side. So for example, we have the list B there, which takes elements from A and B and pairs them all up, or from A and pairs them up with each other. So what we could say is, let's say we want to add the pairs together. So we could say slash. Now this is where it becomes a little bit tricky because I have to pattern match over the shape of the input. I have to specify what the shape of the input is and then tell it how to work with that. Of course, this isn't that bad. In Haskell, we can just say for an x and a y, I want you to return x plus y. And we're going to apply that to B. And there we go. We've got all of the sums of all of the pairs of numbers from A, or from the list B. So this is a very simple way to just apply these higher order functions with some sort of shape or some sort of function that does whatever you need it to. Of course, you can apply other functions in here. You can apply any function you've got within scope. So you can do something complex with lambda functions. If you wish, you don't have to. And of course, we can also use them in function definition. So let's say we have a function x plus y, which returns x times y. It's a very simple function. We can use a lambda function to define this in an alternative way. So we could say f prime takes a y and is going to be equal to something of the shape x goes to y times x. Now here, we're hiding the fact that there's two parameters in the definition, but really this is still a function that takes two functions as two integers and then multiplies for two numbers. So we're hiding that away because normally you would define it as above with f of x plus f of x y equals and then the definition. Here we're saying this takes a y, but also it needs an x to actually carry this out. We could of course take this a step further. We could do f prime prime x, oh no, actually we wouldn't need that, and we could say this is slash x, y, and that goes to y times x. Let's tidy that up a little bit. If we save this and reload, then if we call f prime prime on 2, we should get 4. On 2 and 2, we get 4. And if we do the same with f prime, we get 4. And if we do the same with f, we still get 4. So this is just hiding the input from the definition line. I mean, you wouldn't really need to do this. I would probably recommend that you stick with this definition. But this is just to show you can use lambdas wherever you need to. You can use them in function definitions. You can use them at runtime when you're calling higher order functions. That's an easy place to call them. You can call them wherever you want. They just sometimes help get rid of a definition, help you keep your thoughts in line with where you're going. You could also say that this is quite easy to read. If you have something like map like this, it's quite easy to see that you're taking two elements from a tuple and then adding them together. Whereas if you have some function which is called tuple add or something like that, it might not be so clear what's actually happening under the hood, as it were. So you can put this in your bag of tricks with things like partial application. We'll have another look at that later on. But this is another way to manipulate Haskell and to supply things that are just of the shape that you want. It's an easy way to define things on the fly without having to worry about defining them somewhere else, giving them appropriate name and appropriate type signature. So that's everything for today. That's just a short video on lambdas. We'll see more and more of these as we go through the class. They're very useful. And of course, they're in most programming languages nowadays. Even Java has them. I think you can get them in C and C#, things like that. They're pretty much everywhere. As far as I'm aware, functional programming was the first places that lambdas came out. If you want to see more of these anonymous functions, you can look at the lambda calculus. That's somewhere that this is taken from. And it's quite a well-developed area of mathematics. But that's everything for today. If you have any questions about anything I've covered here today, please do let me know. Thanks.